welcome. I'm Mariam from Data is Good, working as a data science evangelist. At Data is Good, we have trained thousands and thousands of students in our live classes and helped them make successful data science careers. If you are new here, then please do not forget to subscribe to our channel and press the bell icon so that you get all the updates, all the new content, and do not miss out on anything. So in this video, we will look at the normal distribution. So let us start without wasting any more time. In probability theory and statistics, the normal distribution is also called the Gaussian distribution. Normal distribution is the most significant continuous probability distribution. Sometimes it is also called a bell curve. The normal distribution is defined by the probability density function for a continuous random variable in a system. Let us say fx is the probability density function and x is the random variable. Hence, it defines a function that is integrated between the range or interval x to x plus dx, giving the probability of random variable x by considering the values between x and x plus dx. A large number of random variables are either nearly or exactly represented by the normal distribution in every physical science and economics. Furthermore, it can be used to approximate other probability distributions. You can see the curve of the normal distribution on your screen. Now we will look at the standard deviation of the normal curve. Generally, the normal distribution has a positive standard deviation. We know that the mean helps to determine the line of symmetry of a graph, whereas the standard deviation helps to know how far the data is spread out. If the standard deviation is smaller, the data is somewhat close to each other and the graph becomes narrower. If the standard deviation is larger, then the data points are dispersed more and the graph becomes wider and wider. The standard deviations are used to subdivide the area under the normal curve. Each subdivided section defines the percentage of data which falls into the specific region of a graph. Now we will look at the empirical rule. The empirical rule states that approximately 68% of the data falls within one standard deviation of the mean. That is between mean minus one standard deviation and mean plus one standard deviation. Approximately 95% of the data falls within two standard deviations of the mean. That is between mean minus two standard deviations and mean plus two standard deviations. Approximately 99.7% of the data falls within three standard deviations of the mean. That is between mean minus three standard deviation and mean plus three standard deviations. You can see the empirical rule on the screen. Thus, the empirical rule is also called the 68-95-99.7 rule. Now we will look at the formula of the normal distribution. Here it is on your screen, where x is the normal random variable, mu is the mean, sigma is the standard deviation. We will practice an example of normal distribution now. The problem is, calculate the probability density function of normal distribution using the data x equal to 3, mu equal to 4, sigma equal to 2. Here we have a normal random variable that is x equal to 3, mean is 4 and standard deviation is 2. By substituting these values in the formula of normal distribution, we get f3, 4, 2 equal to 1.106. Now we will look at the properties of the normal distribution. In a normal distribution, the mean and mode are equal. That is, mean is equal to median is equal to mode. In a normal distribution, the mean, median and mode are equal. That is, mean is equal to median is equal to mode. Total area under the curve should be equal to 1. Normally distributed curve should be symmetric at the center. There should be exactly half values to the right of the center and exactly half to the left of the center. The normal distribution should be defined by the mean and standard deviation. The normal distribution curve must have only one peak. That is, it should be unimodal. The curve approaches the x-axis, but it never touches the axis, and it extends farther away from the mean. Now we will look at the applications of normal distribution. The normal distributions are associated with many things such as marks scored on the test, heights of different people, size of objects produced by a machine, blood pressure, and so on. So guys, I hope that you are now familiar with the concept of normal distribution. If you have any doubts or need any clarification, then please do let us know in the comment section. Our Data is Good team is always ready to help you out. In case you have any suggestions or any sort of feedback, we would love to hear it. Please mention that in the comment section as well. We will try our best to revert to you and implement them at the earliest. Well, that is all for now. I will see you very soon in another video. Until then, keep learning and stay safe. Bye.